Okay, this is a continuation of the domain and range set notation. I believe I left off on this graph here. Just a quick reminder, we are talking about domain and range, so all the values of x that are possible in this function and the values of y that are possible in this function. As I mentioned before, this is a continuous graph because we have all points connected, and for set notation, we have to remember to include our curly braces, brackets, our letters, and this line that symbolizes such that. Okay, so just like the one before, we're going to go ahead and look at the domain first. So that's the x values. And in this case, I'm going to look at the far left and the far right. Going to the left, I see that this is the farthest I have, and it's an arrow, so that means it's actually like going forever to the left at an angle. So again, on the side, I'm going to go ahead and write negative infinity just for my own purposes. You don't have to write that down. Okay. Going to the right, I see the same thing. Yes, it's going down, but if I think of it in terms of left and right, it's going forever to the right at an angle. So it's also going to infinity. Okay. So when this happens, it's actually kind of nice because this means that it's everything, that it's all real numbers. Remember from yesterday, we talked about all real numbers and how that pertains to information and data. So when this happens, we can just say that x belongs to all real numbers. In other words, this is the setup for all x, that x is pretty much going to take up every value of the real numbers. So forever to the left, forever to the right. Okay? Sometimes you'll simply see that you just have a fancy R and that's it. And again, that just means everything. Okay? If we look at the range now, okay, we're going to start again at the bottommost point and then go to the top because now we're talking about the y values. So if we start at the bottom, we see that the arrow is pointing downward, which means it's going forever the negative direction, infinity. Okay. If we go all the way to the top, our topmost point is at 4. So now that we're talking about negative infinity, we can say that y is less than some number. Okay. So in this case, it's less than 4 because the graph is below 4. All of it's below 4. So I'm going to go ahead and put that here. And if I look at that point at 4, which is this right here, there is no hole or anything. There's nothing like this, okay? If there was, well then, we wouldn't have to put a line, but there's no hole, so we include the equal sign, okay? And that's it for this function. Okay. Go ahead and look at, I believe, the last one. So this is the last one, and of course there are many more cases, but we're going to go ahead and use this as our last example. And just like before, we should identify if this is discrete or continuous. Some of you might see the points and say, oh, it's discrete. There's points that are not connected, but they actually are. They're connected by this curve. So this is a continuous function. It's actually one of the parent functions. This is a kind of extra information. You don't have to write it down, but it's actually y equals x to the third power. It's called the cubic function. Okay, but anyway, that aside, the first thing we should do is our notation. So our curly braces, okay, and x such that, and then we're going to write something there, y such that, okay? So let's go ahead and look at domain first. I'm going to go a little bit faster with this one just because we've already done a few examples. So again, domain is our x values. We look at the far left and the far right. Just like the graph before, okay, you see that this arrow is going forever down and to the left. So we know that it's going forever to negative infinity, forever to the left. Similarly, it is also going up in this case, but it's still going forever to the right. So it's also going to infinity, okay? So in this case, you should know that x is just going to become an element of all real numbers, meaning that this graph, if I were to pick any point, every single x value will be accounted for in this number set, the real numbers, okay? Let's look at the y now. So we're talking about the range. And just like before as well, we also have that it's going forever down. So I know that it's going forever down. And lucky for us, there is actually no top point either. It's also going forever to infinity. So similarly to the domain, we have that y is also an element of the real numbers, okay? Which is nice. This is a nice scenario, okay? If you have any questions, please ask me in class. There are some tricky ones on the assignment. I believe the last one is something weird like this. You don't have to write this down, but good luck on that. You think about it, okay? What are the x values? What are the y values? And hopefully you learned something here.